Good evening to all. Is the audio and video clear to everyone? Say. Thank you. So, any queries with regard to previous session on linear differential equations and Bernoulli differential equation from your side? Anyone? Any doubts with regard to daily test? To anyone, any problems, any questions? Good evening to all. So, I think that the daily test is clear to everyone, which gives a good practice for the methods discussed. Thank you. So let us start our today's session on orthogonal trajectories. I think this topic is already known to you. However, I want to take some of the problems on orthogonal trajectories. Later, I move to the discussion on equations of first order but not first degree. So in which the problems of the type equations solvable for p, x, y and Clairaut's equation will come. So this is about modulo of our today's session. Fine. So please take a note of that. If any doubt is there with regard to the daily test, I will go with the problems first. Otherwise, straight away I start with orthogonal trajectories. Please tell if any queries with you. No problem. Later you can ask the doubts in Telegram itself. Is the methodology and approach clear? How to solve a problem? Thank you. Any other queries for anybody? Fine. So let me give the definition of it. So what is meant by a trajectory? Now let us have a small example that take the equation x square plus y square equal to 4. So what is the picture of this equation if you draw it geometrically? The circle of radius 2. Accepted? Fine. So apart from taking a number here, if I take r square, so here r is not fixed, it is varying. Then what is the graph given by this equation? Say, so here r is a parameter, not a constant. Varies. Any doubts? So we are getting different circles for different values of r. Accepted? Or no? Any doubt with regard to this equation to anyone? Okay. Fine. So, to consider the Cartesian plane, so if you take r is equal to 1, you are going to get a circle of radius 1. If you take r equal to 2, you are going to get another circle of radius 2, and so on. For different values of r, you are getting different circles. We call it as the system of circles or family of circles. I think all of you have come across with this topic earlier. Can I confirm that? Or how many of you are hearing this for the first time? Or you have forgotten totally? Any other inputs? Yeah. Is it fine now? The volume? Thank you. So what happens if you consider a family of circles is given by this equation? Now, if you are going to find any curve, for example, say a straight line, which intersects each member of this family. For example, take the straight line y is equal to x. In particular, y is equal to mx. So if you consider this straight line, this meets each and every member of this family. Accepted? So we say that this straight line is nothing but trajectory for given family of circles. So trajectory means a curve which intersects given family of curves at the fixed angle, because it is possible with a fixed angle. Now, if the angle of intersection is 90 degrees, in other words, the curve intersects the family at right angles, then it is called as orthogonal trajectory. Clear? Any questions? Now, where do we get this type of thing in our real life? Any picture have you seen earlier with regard to them? Anybody? I give one simple example that you take the globe. So obviously it contains horizontal lines as well as vertical lines. So if you take one vertical line, it intersects each and every member of the horizontal line at right angles. Accepted or not? So we call them as orthogonal trajectories. That is one simple example you can say. Another example you can quote is, if you take electric field and a magnetic field inserted, there you can have the orthogonal trajectories. However, if you have studied that type of concept earlier, you have a good idea how to form an electric field and a magnetic field. So those waves are mutually perpendicular. So orthogonal trajectory is nothing but a curve which intersects the given family of curves at right angles. Then, how to determine the equation of the curve? Suppose whenever I have taken the family of curves containing the parameter, the first thing I have to do is I have to obtain the corresponding differential equation. So obviously, you can have the form that dy by dx is equal to some function. It is possible to write like that. Now, we know that dy by dx is also known as slope. If you want to know the slope of this curve, the perpendicular one, what it will be? The product of slopes is equal to -1. So in order to determine the other equation, so we have to replace dy by dx with minus dx by dy. Right side function will be taken as it is. And if you simplify this equation, I mean, if you solve the equation, the resultant is nothing but the required orthogonal trajectory. That is the procedure. Fine. Here, r is a parameter, you call it as a variable. Arbitrary constant, you can call it as. So, r gives different circles with regard to its input value. Fine. Any other queries for anybody with regard to the concept? Okay. Then can I take a problem? Okay. So we subdivide the concept into two modules. That one is we are going to find the orthogonal trajectory when the family of curves is given in Cartesian coordinates. Another one is if the family of curves is given in polar coordinates, then how to determine orthogonal trajectories. These are the two constraints we are going to discuss. So please take the problem. Find the orthogonal trajectories for ay square equal to x cube, where a is parameter. After noting, please inform. So here, consider the given equation as 1 is given in the Cartesian coordinates. So differentiate with respect to x on both sides. Our motto is, on doing differentiation, we should eliminate the parameter a. However, after doing differentiation, if it is not eliminated, by finding suitable substitution for a, we are going to eliminate the parameter. So if you differentiate this, you have 2ay into dy by dx is equal to 3x square. As we know, from the first equation, a is equal to x cube by y square. If you substitute the value here, 2 into x cube by y square into y into dy by dx is equal to 3x square. Now see, we have a differential equation having the independent variable x, dependent variable y, and the corresponding differential dy by dx, and obviously it is not containing the parameter a, so it is our required differential equation. Okay. So from this, can we say that dy by dx is equal to 3y by 2x? Please check. Right. Now, to determine the orthogonal trajectory, we are going to replace the slope. So if you replace dy by dx minus dx by dy, it is equal to 3y by 2x. So we have to mention that replace dy by dx with minus dx by dy. Now you are going to solve the equation. So make it variable separable. So you will have the thing that so on doing integration, minus x square by 2 is equal to 3y square plus integration constant c. Accepted? Three y square by 4, right? So if you simplify this equation, which gives the corresponding orthogonal trajectories, that is our solution. Okay? Any queries in this approach? Now let me take one more problem. So please take the note of it. See, suppose this is the curve, it is given. We are going to get another curve which intersects at 90 degrees. So, if the slope of the curve is dy by dx, what will be its slope? Because product of the slopes is equal to -1. So, its slope is nothing but minus dx by dy. Because the differential gives the slope. Clear? Right. Any other queries, please? If it is clear, I want to take the another one. So, as per the examination point of view is concerned, let us take a typical one which gives you a good idea. Show that x square by a square plus lambda plus y square by b square plus lambda equal to 1 is self-orthogonal. Yeah. Now please understand one thing, that self-orthogonal is nothing but the system of curves which you have taken intersects within itself perpendicularly. That means the system itself intersects at right angles. Such type of family of curves is called self-orthogonal. So, how to prove that the given system is self-orthogonal? The procedure is, we have to eliminate the parameter first and obtain the differential equation. So, obviously, it contains the differential dy by dx. Now, on replacing dy by dx with minus dx by dy, the differential equation which you have obtained earlier will come again. So after replacing the differential, the previous differential equation will come again, so that whenever the same differential equation appears on replacement, what does it mean? Whatever the equation here will automatically the solution of this differential equation. So the system itself is self-orthogonal. So in this way, we prove that it is self-orthogonal. Is the methodology clear? Say, any other queries? Fine. So for this problem, lambda is the parameter. So by doing differentiation, we have to eliminate lambda and we have to obtain the differential equation. So please take a note of that. So let us have the reciprocity so that we will have a good discussion. So I am going to differentiate this equation. So 2x by a square plus lambda plus 2y by b square plus lambda into dy by dx equal to 0 on differentiating with respect to x on both sides. Now you can cancel 2. So x by a square plus lambda plus y by b square plus lambda into dy by dx equal to 0. So here I am going to eliminate lambda by the following procedure. First of all, by doing simplification here, I want to find the value of lambda. Later, since the value of lambda is known to me, I am going to find a square plus lambda and b square plus lambda, and I am going to substitute here, so that total lambda will be eliminated, which is my required differential equation. Later on, I am going to replace dy by dx with minus dx by dy. Fine? Yes or no? Right. Another thing is, for writing convenience, I am going to represent dy by dx with a symbol p for our convenience. So here, let us do the cross multiplication first. So x into b square plus lambda plus yp into a square plus lambda equal to 0. On doing LCM, this is the value. Now you multiply each and every term, take lambda as common, and you are going to get the value of lambda. So I say that lambda is equal to minus b square x plus a square into y dash by x plus y dash. I mean, just hold on a second, I am going to replace that. Please check on that. Any queries to anyone? Say. Right. Now, let us find these two values. So a square plus lambda is nothing but a square minus b square x plus a square yp by x plus yp, which gives that a square plus lambda is equals to please check that. Similarly, b square plus lambda is also equal to 2. A square minus b square into yp by x plus yp. Please check. Accepted? I think you are doing simultaneously with me, so the doubts will be clarified. Yeah, b square minus a square. So can I put minus here? Fine. So substituting these two values at this position, so I will have x into x plus yp by a square minus b square minus yp into x plus yp by a square minus b square into yp is equal to 0. Yeah, please check on that. So you are going to take x square here and y square here. Say, am I correct? Yeah. Now okay it is. I am going to substitute a square plus lambda and b square plus lambda values here. So we are going to substitute the values in this equation. Yeah, just hold on a second. So if you substitute x by a square plus lambda is nothing but please check now. So we are going to substitute the values in the given equation. Accepted? Right. So if you take common in the numerator x plus yp and a square minus b square goes to the right side, then you have x minus y by p into x plus yp is equal to a square minus b square. So here you can observe that the given parameter lambda is completely eliminated and p is nothing but the differential dy by dx. So it is our required differential equation. Accepted? So to determine the orthogonal trajectory, as we replace dy by dx with minus dx by dy, so we have to replace p with minus 1 by p. So if you replace p with minus 1 by p in this equation, you are going to get x plus yp into x minus y by p is equal to a square minus b square. Accepted? So on doing the replacement also, the same equation appeared here. Hence, the given system is self-orthogonal. That is the conclusion of the problem. Please check the approach. Any queries? Say. Right. Shall I go to the other one? On this Cartesian coordinates model? Right. So take the problem that find the orthogonal trajectories for the family of circles x square plus y square minus 2ax equal to 0, where a is parameter. So after noting that, please inform. Now, one typical thing we can notice that apart from straight away giving the equation, find the orthogonal trajectories for these curves, we can ask that mentioning the nature of the curves, we have to determine the equation first in which the parameter lies, and later on you are going to follow the regular procedure. Accepted? So from the given equation, what we can say about that? The given equation represents, is it a circle or not? Say, right? So the center lies on x-axis. Can I say that? So the question will be asked as, find the orthogonal trajectories of family of circles whose center lies on x-axis. Can I take like that? All of you agree or not? So I think one thing I can say, in calculus part of paper 1, we come across the thing that curve tracing. So there you are going to draw the graph of the curve provided the equation is given to you, and at that mode you are going to get different words like hypocycloid, parabola, confocal conics. Can you get an idea about these words? Did you come across them? Have you heard it? Say. So apart from straight away giving the equation in this model, he can use the technical word so that we are going to get the equation first on reading the statement of the problem, then the usual procedure will be applied. So that is one type of typical thing you can expect from orthogonal trajectories concept. At the most, that thing usually won't happen in examination point of view. in every question he will directly give the equation like this. Fine. The maximum complexity you can expect in such a way. So here A is the parameter. Let us do the differentiation first. So if you take that, this is the given equation. On differentiating, you have 2x plus 2y into dy by dx minus 2a is equal to 0. From this, a is equal to x plus y into dy by dx. So substituting the value of a in the given equation, we will get the required differential equation as x square plus y square is equal to 2x into x plus y into dy by dx. Substituting the value of a in the given equation 1. So later, if you simplify that, I will write the equation straight away. You please check. Accepted? So please check and tell. Because majority of you have done this kind of problems earlier. Since the parameter a is eliminated here, so let us replace the differential dy by dx with minus dx by dy. X square minus 2xy into dx by dy minus y square equal to 0. Now we have to solve this equation. So you can write in the other manner that dx by dy is equals to, that also you can write. Now, can you recollect the approach of solving variable separable differential equations and homogeneous differential equations, say? You get the idea any? So, whenever you write the function as dy by dx is equal to something or dx by dy is equal to something, if the right side function is homogeneous, means each term has the equal power, power 2, power 2, power 2. In such case, we have a technique. We use the technique that we put y is equal to vx or y by x is equal to v. On differentiating, we have dy by dx is equal to v plus x into dv by dx. Or in the other model, you can put x by y is equal to v, that is x is equal to yv, so that dx by dy is equal to v plus y into dv by dy. Can you recollect this procedure? Solving homogeneous differential equation? Right. So here tell me which thing we have to use, y by x or x by y, as per the equation is concerned here. X by y. Because here you have the differential dx by dy is equal to something. So we are going to put x is equal to vy. So dx by dy is equal to v plus y into dv by dy. So this thing we are going to use here. So let us substitute the values here. So you have v plus y into dv by dy is equal to, so x is equal to yv, so v square y square minus y square by 2x into, so x is nothing but yv, so y square v. So y square gets cancelled, so y into dv by dy is equals to v square minus 1 by 2v minus v. Accepted? Please check on simplification. And we have to do it variable separable, then you are going to get the solution again. So here, this implies that y into dv by dy equals to v square minus 2v square. So minus of v square plus 1 by 2v implies minus dy by y is equal to 2v by v square plus 1 into dv. So on integration, we have the integration constant log c minus log y is equal to log of v square plus 1. Accepted? Please check on the solution what I have done. Right. So, on the whole, while doing orthogonal trajectories under Cartesian coordinates, we come across three variations. The first one is usually finding orthogonal trajectories. Second one, we do finding orthogonal trajectories in which we have to solve the equation which comes under homogeneous type. The third one is we are going to determine that given system is self-orthogonal. These three are nothing but the variations under Cartesian coordinates. Clear? So I have discussed the maximum complexity also in this orthogonal trajectories. Any questions, please? Yes or no? The maximum variations, usually finding orthogonal trajectories. Another one, orthogonal trajectories in which while solving we get the homogeneous model. Third one, self-orthogonal. These three categories come under the Cartesian coordinates. So we have to do the problems on polar coordinates also. Right. Any queries up to this model? Yes or no? Fine. So I am going to take the next one. So coming to orthogonal trajectories for polar coordinates. So as we know, we represent x and y as x is equal to r cos theta, y is equal to r sin theta. So here, whenever the equation is given in terms of r and theta, having a parameter, so we say that the given family is given under polar coordinates model. So what happens? Usually we have to differentiate. So here we need to understand that r is a function of theta. As we know, y is a function of x. We do dy by dx. So here r is a function of theta. So we have to differentiate dr by d theta. So here the differential is dr by d theta. In order to find the corresponding orthogonal trajectory after eliminating the parameter, we have to replace the differential dr by d theta with minus r square into d theta by dr. So replace should be done like this. Okay. minus r squared d theta by dr, right? So please take a note of that, and we are going to do some problems on it. Here, how to replace the differential. Fine. So let's take the problem. So find the orthogonal trajectories for the family of curves r equal to a into 1 minus cos theta, where a is parameter. Also, apart from straight away giving the equation, he can mention that family of chordioids. I think this word is familiar to you. Okay? Yeah. So apart from giving this equation, he can use this word. So find the orthogonal trajectories of family of chordioids where a is the parameter. Our parameter need not be mentioned. Okay. So let us do the problem. So take it as the given equation. So differentiate with respect to theta on both sides. So we have dr by d theta is equal to a into sin theta d theta accepted. No. While doing calculus, we have the lecture on curve tracing. Actually, curve tracing is only meant for whenever an equation is given, we are going to draw the picture of that curve, which is mostly useful while calculating the areas and volumes of multiple integrals, where it is mostly useful. I think it was not yet covered to you so far. Of course, giving the priority of the previous topics and previous year question papers, the lecture is not included there. But while doing the multiple integrals in which we are going to calculate area and volume, there we can have this concept of curve tracing. I mean, how to imagine the curve shape and how to find the area or volume described as per the problem. Yeah. Since no question is framed, that part is set aside, and while doing the multiple integration, it will be taken as a sub part of it, not exclusively. Mainly chordioids, hypocycloids. Yes, it is important to understand the concept, that I agree. Which I agree. Yeah, it is there. In engineering mathematics textbook, it is there. You can have BS grammar. Straight away, you can look at the so many curves pictures. So knowing the curve picture and equation is enough. There is no need to determine how the shape of the curve existed there. How the shape of the curve is existed there. That is not necessary. Since the equations are fixed, if you know how to write the equation of the curve, I mean based on the pictures which are there, it is enough to calculate the area and volume. bounded by the shaded region. That is enough. Because that is the only part asked in examination point of view in multiple integration. Accepted? Okay. Yeah. Asymptotes that will be covered separately. See, I can say up to 2000, 2002, questions are asked on asymptotes and curve tracing. Later on, we can have the less priority with regard to curve tracing and asymptotes in the previous year questions. That's why they have set aside. Can you have a look over the calculus portion earlier? So if you look at it, right from 2010 to 2017, how many questions are framed on curve tracing or asymptotes concept? Hardly one or two. So coming to the weightage given to other concepts, we set aside. Right. So can I continue now? Yeah. Whatever the parts are left over for you, you please inform. We are going to take them separately. And if the recorded videos are eligible there, I mean available there, we post it. Sure. So I want to take the ODE part up to the concept of Laplace transforms. Later, Venkana sir will resume the session. Right. Fine. So let us go with it. So if you substitute the value of A there in the given equation, so we have R is equal to 1 by sine theta into 1 minus cos theta into dr by d theta. So we are going to simplify this. So in the numerator, I am going to write it as cos 2 theta by 2. And here, I am going to write it as sine 2 theta by 2 into dr by d theta. So it is of the form 1 minus cos 2x, the value is 2 sine square x. Am I correct there? Right? And here sine 2 theta, it is 2 sine theta by 2 cos theta by 2. Implies R is equal to tan theta by 2 into dr by d theta. Please check on this. Now we are going to replace dr by d theta with minus r square into d theta by dr. So where you have the doubt? This part. Okay. Yeah. So this is our given equation. R is equal to A into 1 minus cos theta. Differentiating with respect to theta on both sides, dr by d theta is equal to A into sine theta. From this we have A is equal to 1 by sine theta into dr by d theta. This value is substituted in the given equation to eliminate the parameter A. So that we have R is equal to 1 minus cos theta by sine theta into dr by d theta. To simplify that, cos theta is written as 2 into theta by 2 and sine theta is written as 2 into theta by 2. So we have the formula 1 minus cos 2x is equal to 2 sine square x, and sine 2x is nothing but 2 sine x cos x. So these formulas are used here and this is our result. Fine. So here x is nothing but theta by 2. Now we go for the replacement to get the orthogonal trajectory. So if you replace r is equal to tan theta by 2 into minus r square d theta by dr, square r gets cancelled. So we have to do the variable separable. So dr by r is equal to minus tan theta by 2 into d theta. Since it is variable separable, doing integration log r is equal to minus 2 into log secant theta by 2 plus log c, you can take the integration constant. So we have log r is equals to, we have secant square theta by 2, I mean log of c by accepted. So there you can go for the further simplification, cancelling logarithm on both sides and doing the other part. However, if we have done up to that, answer is valid and marks will be awarded. Okay. So let us take one more big problem. I mean, a typical problem on polar coordinates. Here we can have one small discussion under this trajectories concept, so that we can totally wind up our discussion on orthogonal trajectories. Shall I continue? So find the orthogonal trajectories of r power n sin n theta equal to a power n, where a is parameter. So we can expect this model will be asked frequently in exams, and the previous one too. I can say the question r is equal to 2a by 1 plus cos theta is asked earlier under orthogonal trajectories. So if at all polar coordinates problems are given for orthogonal trajectories, this one and the previous one we have discussed are usually important. Okay. So let us solve that problem. So let us differentiate with respect to theta on both sides. So here you have two things. Sin n theta is a function of theta, r is a function of theta. So you have to apply the product rule here to have the differentiation. So if you go for differentiation, r power n into for sin n theta cos n theta into n plus sin n theta into r power n differentiation n into r power n minus 1 into dr by d theta equals to 0. So this is the differentiation part. Please check. So this is one kind of differentiation. Another one, you can apply logarithm on both sides too. That is also acceptable. If you apply logarithm on both sides, then you have on the right side n log a is equal to, here you have n log r plus log sin n theta. That also you can apply. Both the things are acceptable to get the same answer. Fine. So do you accept for this differentiation or not? Yes or no? Right. So here you can cancel r power n minus 1, also n. So r into cos n theta plus sin n theta into dr by d theta equals to 0. So this implies dr by d theta is equal to minus r cos n theta by sin n theta. So it is our required differential equation. So let us replace dr by d theta with minus r square into d theta by dr. So r square gets cancelled, minus gets cancelled. Let us go for variable separable. So tan n theta d theta is equals to dr by r. So doing integration, log secant n theta by n is equal to log r plus log c. So you have so this will be our required answer. Please check on that. So on either side, you can take the integration constant. On this side, on this side. So depending upon the integration constant taken side, the simplification will vary. So that the evaluator takes the thing up to the integration part. So simplification is done according to your convenience. Okay. So is this clear to all? Polar coordinates as well as Cartesian coordinates. So let me take one other thing, that apart from taking 90 degrees, that is apart from finding orthogonal trajectories, if the problem is given that find that trajectory only, which makes 30 degrees angle, 40 degrees angle, 60 degrees angle, like that. That also one type of question you can expect in the examination point of view. Okay. So I just want to take one problem which gives an idea. So later on you can practice. So can I erase this? Are you getting the idea or not? What I am saying? Fine. Just hold on a second. So here we go. Suppose a family of curves are given to us. Consisting or having a parameter. So by eliminating the parameter, we are going to get the differential equation of it. Now we are going to find the trajectory, nothing but the curve of intersection for the given family. So usually whenever the curve intersects, it should make an angle with the given family. So if you say that theta as the angle or alpha is the angle, whatever you say, so by taking the respective angle 30 degrees, 45 degrees, 60 degrees, etc. So we are going to find the trajectory which cuts the given family of curves at a particular angle. It is our objective in this concept. Okay. So here if you denote that dy by dx is equal to p, the differential. So in order to determine the trajectory, as we are going to replace that, so we are going to replace it as please take a note of this formula. So this type of trajectories, we are going to call it as oblique trajectory. So did you come across that word? So oblique trajectory is nothing but the curve which intersects each and every member of the given curves at a fixed angle. So let me take one thing. Now say this is a curve which is cutting each member of this family. Can you say that is this angle fixed here? Yes or no? Right? If you take the same family again, so can you say that this curve is going to cut each member at a constant angle? Do you accept at least? So this kind of trajectory, we call it as oblique trajectory. So it is just a trajectory which is not oblique trajectory. Okay? I think the concept is clear to everyone. So what is the procedure here? Once the given family of curves is given, obtain the differential equation by eliminating the parameter. We use the symbol dy by dx for p or p for dy by dx. To determine the trajectories, replace p with p plus tan alpha by 1 minus p tan alpha, where alpha is nothing but the required angle given in the problem. Okay? Is it clear now? Yeah. So please take a note of the problem. Find the oblique trajectory for the family of hyperbolas xy equal to c with the angle pi by 4, where c is parameter. The angle pi by 4, where c is parameter. So is the question clear? Fine. So can you eliminate the parameter c by simply doing the differentiation? So I write the equation straight away that if you differentiate that, you are going to get it as y plus xp equal to 0 is the differential equation for the given family where p is equal to dy by dx. Accepted? Right. So in this differential equation, we have to replace p with p plus tan alpha by 1 minus p into tan alpha. This is the formula. So to get the oblique trajectory, y plus x into p plus tan 45 degrees by 1 minus p into tan 45 degrees equal to 0, which is our required equation. So if you simplify this, y plus x into 1 plus p by 1 minus p equal to 0. Is it clear? So from this, right away we can say that now how to solve this equation? Any inputs? Yeah, we can calculate P too. So if you calculate P, I say that P will come as, please check the value of P, y plus x by y minus x. So earlier I have given that the homogeneous method by taking that y is equal to Vx and dy by dx is equal to P plus x into dy by dx. Using this technique, we are going to solve the problem. So can I leave here so that you are going to solve the problem by doing the substitution? Right. So the maximum complexity under trajectories part is this kind of problem. So nothing different is there. You just have to remember that what is to be replaced with what. That's all. So that is the formula for the replacement, and there you are going to find the respective trajectories. Clear? So here I wind up our the discussion on orthogonal trajectories. Can I start a new topic then? Okay. So since the time is running out, I will give an overview of the topic what I am going to start, and then in tomorrow's session we are going to do the problems. Yeah, the answer is available to you. So I simply say that, just hold on a second, I will write the solution part 2. Simplification as per your convenience. Just answer. I will say that log x square plus log of v square minus 2v minus 1 is equal to log c. And you are going to substitute v value. So the final answer will come like, I am doing simplification will get the answer like this. Fine? Right. How x square? You are going to get 2 log x, so that x square will come. So I am going to write the, you can check on the step that x into dv by dx is equal to you please check on that. Accepted. Right. Thank you. So let us start the concept that so equations of first order but not of first degree. So far, whatever the problems we have discussed, we simply stick on to the differential dy by dx in the given equation, which has power 1 in the given equation. So we have not yet solved the problems such that dy by dx contains power more than 1, dy by dx whole square, dy by dx whole cube, etc., etc. However, in the concept of change of variables, there we have solved dy by dx whole square problem up to certain extent by taking that dy by dx is equal to p, and you are going to make it as variable separable, and further you are going to solve it, right? So that is one thing. If at all dy by dx whole cube whole power 4, those things are there, then how to solve those equations? So that category will come under the concept of equations of first order but not first degree. So mainly whatever the equation is there, for our writing convenience and solving purpose, we use the symbol as dy by dx is equal to p. So here onwards, whenever p symbol is presented in the equation, we have to understand that p is nothing but the differential dy by dx. So every problem under this category is classified into 4 models. Equations solvable for p, solvable for y, solvable for x, and Clairaut's equation. So what is meant by solvable for p? Let us have a small problem that so do you accept that this is a first order differential equation and degree more than 1, say? Right. So we are going to write it as p square minus 5p plus 6 equal to 0, where p stands for dy by dx. And are you going to write it as factors of p? Yes or no? So you are going to write it as p minus 2 into p minus 3 equal to 0, so that p is equal to 2 and p is equal to 3. So solving for p is nothing but whenever a given differential equation is possible to write or represent as linear factors of p minus something dot p minus something equal to 0, then such equation will be called as equations solvable for p. Usually whenever the given equation is there, by simply rearranging the terms or splitting the terms. You can check that taking the common values is possible, and it is possible to figure out it as product of factors or writing as product of factors. So whenever this kind of equation is there, we call it as solvable for P. Since P stands for dy by dx, so dy by dx is equal to 2, dy by dx is equal to 3. So we are going to solve each factor individually, so that dy is equal to 2 dx. So y is equal to 2x plus c. Here also we have y is equal to 3x plus c. The corresponding solution is so this is the required general solution, right? So how to obtain the general solution? First of all, we need to write the given equation as product of factors in P, either by doing straightly or directly, or doing the rearrangement of the terms. Then we have to solve each factor individually, and the final solution is represented in the product form. Clear? Yes or no? Second thing is equations solvable for y. Whenever the first case is not possible, that means doing factorization and taking common in the values for the equation is not possible. In such cases, the remaining 3 cases are possible. How to check that the given equation is solvable for y or solvable for x? The simple thing is, in the total equation, y must has power 1. So that what happens, you can rewrite the equation as y is equal to something. Most probably, the right side thing contains only x and p terms. Similarly, in the whole equation, if x has power 1, then it is possible to write the equation as x is equal to some function of y and p. So on the right hand side, you have y and p terms are there, remaining will not be presented. So this equation is called as solvable for y, and this equation is called as solvable for x. So how we are determining that? Only based on power of y. So if y has power 1, it is solvable for y. If x has power 1, it is solvable for x. Okay? Yes or no? Right. Now, take the first case. After representing y is equal to something, differentiate with respect to x on both sides. So left side, what will come? dy by dx, nothing but p, is equal to, on doing differentiation, we will have respective terms. So this entire expression will be written as product of two things equal to 0. I repeat again. First step is we represent the equation as y is equal to something. Later, we differentiate with respect to x on both sides. So p is equal to something will come. The whole equation is simplified by taking the terms common. It is represented as product of two factors equal to 0, in which what happens, one factor will not contain any differential and one factor will contain a differential. So whenever product of two things is 0, each factor must be equal to 0. Yes or no? So what happens in the two factors? We consider the factor which contains the differential only, and we neglect the other factor. For example, let me take that suppose this thing has occurred. So product of two things happened. This value is equal to 0 and this value is equal to 0. Let me say the thing as right. From this, what will be the value of P? Can you say? What will be the value of P? Right. So, will that value contain any constant? No. So, what happens? You have achieved the value of P straight away. So, as we know that solution of a differential equation is nothing but a relation between x and y which contains the arbitrary constant. So in every solution we write that x square plus y square is equal to 2xc, like that. Accepted or not? So every solution of the differential equation must contain the arbitrary constant. You take this thing for convenience. So 1 plus 2xp into y plus dp by dx equal to 0. This contains the differential dp by dx. It won't contain any differential. It is simply 1 plus 2xp equal to 0. From this, p is equal to minus 1 by 2x. You have achieved the value p straight away. Now what happens? If you substitute the value of p minus 1 by 2x in the given equation, straight away you will get a relation between x and y which will not contain the constant c. But it is also a solution of the given differential equation. So such a solution is called singular solution. So if you look into the syllabus, singular solution is obtained like that. However, if you take this case, then what happens? Y plus dp by dx is equal to 0 or x plus dp by dx is equal to 0. From this, are you going to get the arbitrary constant or not? So, which gives a solution which contains a constant which is required solution? That is the procedure. So, however, in tomorrow's session, I am going to take the problems on the two concepts so that we have a better understanding. What is meant by singular solution and what is meant by general solution. Okay? Right? So that's all for today. Let us wind up our session here, and tomorrow we will meet. And I will give the list of problems on the orthogonal trajectories. You can have a good number of practice.